Oh, what's up? So, video 3 in our Circuit Playground series, video 4 in the entire channel. We got some good stuff. So, a little bit of background on what's going on the past week or so. I've been doing a lot of behind the scenes work on the Circuit Playground, and I've gotten pretty good at it. Not to toot my own horn or anything. So basically, I've kind of decided I want to do a lot larger projects with the Circuit Playground, start using stuff like servos and stuff, making it a little bit more difficult. But before I went on with that, I wanted to first get the basics of everything and show, I guess, what the Circuit Playground can do and all of its basic features. So this video is basically just going to be me kind of showcasing, I guess, the other features of Circuit Playground Express right here. There's a lot of sensors that you can use, and I was just using a lot of them to make different projects. So in this video, I made 3 different projects that use a lot of the newer sensors on the Circuit Playground Express that we haven't explored before. And I'm just going to kind of showcase those and talk about them and show the code a little bit, just to introduce them. So yeah, let's get started. Alright, so project number 1 that I was working on. This is a thermometer, so turning the Circuit Playground into a real life thermometer. And basically for this one, how it works is I use the 2 button inputs to show the degrees Fahrenheit that it was. The first button would show the tens digits, and then when you would press it, it would show you the ones. So yeah, I'm just gonna go a little bit more in detail to what the temperature sensor does, and then kind of show the code, and then show what the actual I guess project does. So let's get it. Alright, so live look at the code. Basically what I do here is when it starts, I just have variable named singles, which is basically having it show single digits. Set that to false. And simply put, it says if button A is pressed, singles is true. And then if button B is pressed, then it becomes the tens digit. So if we look at it here, 82 degrees Fahrenheit, as you can see, 82. And then when B is pressed, it goes back to the 8 on the outside. And then here it just says if singles, then call singles temperature, and else calls tens. And then just looking at the function real quick, the singles temp and tens temp. Basically, singles temp is saying if the temperature is greater than 40, give the ones digit, take the ones digit of the temperature, and then for index 0 to however many that would be, just give that many red button lights to light up. And if it's less than 40, then they will all be blue. So let's say I go here. We have, let's see, 33. Maybe not 33, because then that's the same. 37. So here we have 3 is our tens digit, 7 is our singles. So when we go here, 7 is our units. Pretty simple. And then here, just if the temperature in Fahrenheit is greater than 100, show 10, 99, 88, 50, and so on and so on. And this could also be programmed in this way, where it's basically saying kind of for index in this range, if it was 90, for just make sure you light up 9, the first 9 of them. Honestly, either of these ways for coding works. This one takes a little bit more time to load. Just wanted to show the different ways that you can kind of go about this. So yeah, I'm just gonna give a live demo, and we'll get back to it. So welcome back. How y'all doing? This is just a quick snapshot of how the temperature, I guess, thermometer works. So we got our tens digit right here. I just started the program. I can just reset it real quick. So it starts off by giving us the tens digit, and then if I press this button, it'll take me to the ones digit. So right now it's 73 degrees, and then take me back to the tens digit, 7. Just a little bit of kind of working through stuff. This A9 right here, this sensor, this is your temperature sensor. So this is really, that small sensor is getting all the temperature input in the Circuit Playground Express and sending that to the microprocessor, which is sending that to the code, and it's basically from there it's just being turned into outputs. So that small little sensor right here is getting everything done, and then of course the buttons are providing the inputs. So just one more time, press that A button, it's a 3, and then back here 73. I hope y'all enjoyed that demo. Second project that I've been doing is one that uses a light sensor, and basically the general premise is that if your Circuit Playground ever gets into a really dark spot, then you would be able to find it, because it'll make a sound and it'll make a noise, and it uses the light sensor to basically understand if it's actually in that dark place or not. So yeah, I'm just gonna showcase the code and let's get it. So what's up? This code is really simple, really easy to follow. Basically just taking y'all through it, sets the volume to 99 and sets the brightness to 175. Therefore it's a pretty loud and pretty kind of bright, light. Can't really miss it. And then basically it says if the light level is less than 15, then show an animation for 2000 milliseconds and to play a sound until it's done. And I just wanted to show something really quick that I think is really cool, especially for people who are trying to calibrate their machine. This was a feature that I used to really get this number 15 right here. So you go here into the console and console log, and basically what you could do is you could log your light level. So this is just going to show for the simulator, but you could also, if you have the app downloaded and not from the website, you can also do this for your device as well. So basically I'm just going to show real quick what it's showing. It's just this graph basically, and the 128 that you see right here is the 128 right here. As I increase or decrease it, so right now I'm decreasing it down to 48, you can see that it's also taking these inputs as well. And then if I increase it, boom, there you see that sharp increase, and if I just go like this, you can see those lines, and this can really be helpful if you're just trying to find that perfect value where it works the way you want it to, and if you're trying to calibrate it. So just wanted to share this with y'all. It's something really helpful when you're trying to kind of just iterate and test, and it really helps you understand what's going on. So I really used that when I was trying to find the optimal light level where it wouldn't just be kind of susceptible to any type of light, but it also wouldn't be too dark where it wouldn't be able to see anything, or it wouldn't be able to actually turn on. So yeah, that's basically the code. It's pretty easy code, but it gets the job done. Alright, so here we are. Just like I did before, just gonna quickly just show the sensors that are being used here. We're actually using 2 different components on this Circuit Playground, and I believe one of them hasn't been used before. So the first one is right there, A8, and that's basically our light sensor. And what it does is it senses the light from 0 to 255, and it returns that as an input that can be used for outputs for our code. And it's always continuously looking at that light input, and it's making sure that the light input is actually like continuously updating, and that it's matching like kind of the real world surroundings. And we'll kind of get into like how it works a little bit. It basically just senses like how light or dark, I guess like the plane in front of it is, and then it sends that to our microprocessor over here. And then the second thing that we have is an alarm, or I guess like a speaker. So that's right here, and this basically just plays music, and whatever music you want it to play, you can just program it to play it at a certain volume, a certain pitch, and it can actually be pretty versatile in kind of playing a lot of different songs. It gives you, Circuit Playground gives you the option to do like 3 different octaves of just kind of notes that you can use, and it allows you to use all the sharps and flats. So realistically, like any song that you want to play, you could play and program it to play on your Circuit Playground Express. So that's kind of just the general gist of everything that's working here. Now I kind of just want to showcase the code real quick. So I have my servo box here, and if I put it in here, the light sensor sees that it's a lot darker, and it keeps playing and playing. So just one more time, I'm gonna put this inside just so you can see what's going on. So here we go. I'm just gonna reset it. So here we go. And it lights up and plays. I'll also set the volume a little bit higher, just so you can be able to hear it. Alright, so yeah, that's basically kind of just how this one works. This is gonna get really annoying. But also, now that you can see that it's been found and it's put out into the light, it stopped. So it's really an adaptive thing, and it keeps on working. So yeah, this is just kind of how the second one works. And then I'll be going on to the final project. All right, so I hope y'all enjoyed that second kind of light sensor, speaker system, anti-loss type of code. And this last one is arguably my favorite, that project that I've done so far. And I was thinking about making it its individual video, but I think that wouldn't be doing the other 2 projects justice. So this last one is one that responds to sound input. And it's basically a clapper machine where you clap, and then I guess kind of the Circuit Playground receives that, and then is able to show the pattern that you did back to you, which will make sense a little bit as I show the code and also demo it as well. So let's get into it. All right, so this is the code for, I guess, our clap playback machine. So it looks really really complicated, but it's pretty simple. So on the start, basically we reset the timer, and we have an array of times, which is basically just a list of times, and we empty that, and then we set the showcased feature to false, which I'll get to. So basically what it's saying here is if, like, during the first 10 seconds of the timer, so we set a timer and we say in these 10 seconds, log the sound level and log the timer kind of, I guess, time that's passed. And then we say, like, if the sound level around it, so if the microphone gets the sound level that's more than 160, add that time value, add that time frame where that was over 160, add that to the list, and then also flash very brightly. And then else just clear the lights so that it kind of is very interactive. And then after here we say else, basically if we haven't showcased like what the user has done yet, then what we will do is actually showcase it. So we'll say for index from 0 to 1 minus like the last length of the array, we're going to say flash a light, and then clear, and then pause for a time, the time interval between the first and second claps. So that's just kind of a quick understanding of it. Basically what it's doing is it's getting the value before it, and then also the current value, subtracting them, and then that's the wait time that you have between the two, which allows you to simulate it allows you to simulate the clapping that you did. And then it just sets showcase to true, so that when it goes here, showcase is equal to true, so it won't be able to like keep on doing it. So that's just a quick kind of update on the code. Alright, so this is just kind of going over the hardware that was used here. The main one is the microphone, which can be found right here. Right over here. And basically what the microphone does is it listens for input, and then based on kind of how loud the input is, it returns a value from 0 to 255. That basically says like this is how loud your program is. And then, but that's basically used in the microprocessor for a bunch of different outputs. And then the other thing that we're really using in here that I haven't really used before is the timer feature, which is just in the console. And the timer feature just basically keeps track of how much time has passed once you have began your first like reset. So those are just the two main functions that I've used. And then of course I use the light sensor, but I've showcased that a lot in this video and then also my previous videos. So let's get a quick demo. All right, so it's downloaded. Now I'm gonna start my claps. So now it's doing its own. And there we go. I'll just do it one more time. This quick download. Let's see how it does. And there we go. So that's just kind of the last one. This is personally my favorite one, just because of how interactive it is and how it kind of uses the light sensor, the microphone, the light sensor, and also like the timer to really create something that I think hasn't really been done before. So yeah, I hope you enjoyed this one as well. Like kind of just tinkering around and playing with those projects really helped me to work and really get to know Circuit Playground Express. And I really think I've understood the basics and fundamentals really well, or at least well enough to be able to create like these kind of projects and stuff. And that was just an overview, I think, of really all the sensors on the Circuit Playground Express that I've been using. The only one that I think that we haven't used is the ambient color feature, which is kind of like the light sensor, but just a little bit more of color. But maybe something like that in the future, I don't know. I hope y'all enjoyed like these, at least like these like first 3 videos where I was trying to figure stuff out and work with stuff and troubleshoot. And basically now that I have all these basics, I'm going to begin going into a lot bigger projects, a lot larger things. So we got our servo motors here, which is what I'm planning to use next. Using them to be able to kind of like move around different things and be able to do more automated things in projects, which would be kind of cool. Yeah, and so I'll just be working on a lot larger projects and showcasing them. I hope y'all enjoyed. I think this was really fun to make and just be able to showcase a lot of these things. And I hope it also motivates you to kind of try something like that on yourself. They're only $25. So yeah, I mean, honestly, just pick one up see what you can do with it and have fun. Also, like, this is probably going to be the last time that I'm really working with MakeCode. I know the block structure looked really nice, but it's kind of limited in what you can do. So I will be kind of moving on to CircuitPython, which is just the coding, more advanced coding language that allows me to do a lot more with just motors, and just I'll use a lot more libraries as well. So yeah, I mean, it's a new chapter, and I hope you all are ready for the ride. So peace.